In Congress in the United States, we have 100 senators, 2 from each state. Well, 3 of the senators, out of the 100 senators, must be chosen to travel to an international conference. It could be any 3. In how many ways could the 3 senators be chosen? So the arithmetic, the math part of this is simple. You need to be able to tell me, is it a combination or permutation or what? Well, chosen, choose. So what we're doing is 100 choose 3. So the answer is this. Now this is not going to be acceptable as a final answer. You'll get partial credit for that, of course, but it says simplify. So this would be 100 factorial over what? At least in your mind, what are the 2 factorials going to be that go on the bottom? 97 factorial, 3 factorial. 100 minus 3 is 97 factorial, and then 3 factorial. And I'm going to put the 3 factorial where it is. How do I cancel the 100 factorial over the 97 factorial? 100 factorial is 100 times 99 times 98 times 97 factorial. So the 97 factorials would cancel, leaving me 100 times 99 times 98. And the 3 factorial is just equal to 6. Let me just go ahead and put a 6 there. 6 is equal to that. 6 times 16. Let's see. 6 is not going to go into 99, but I could cancel the 6, 3. Yeah, let me just plug it into the calculator. Why not? I'm going to divide this by 3 and make it a 2. Sorry, I'm going to divide it by 3 and make it a 2. Divide that by 3 and make it a 33. So 99 over 6. I divided them both by 3, giving me 33 over 2. And then I could cancel the 2 with either the 98 or the 100. I'll cancel it with the 100 and make it a 50. So in my calculator, I'm going to write 50 times 33 times 98. That is 161,700. Wow, that's a big number. But you started with 100 people. How many ways could you choose 3 different people? This many ways. All right, number 12. And some of you, when we read this, are going to know the answer instantly. Exactly 97 senators are required to attend a certain vote. All 100 senators are available, but only 97 will be chosen for the meeting. In how many ways could you choose 97 senators out of a group of 100? 100 choose 97, or C 197. And I know some of you already know the answer, but I'm going to go ahead and use the formula here. The numerator is 100 factorial. What's the denominator? 100 minus 97 is 3. Then you put a factorial on it, and then 97 factorial. Well, that should look familiar. Exactly the same answer, 161,700. Again, 97 and 3 add up to 100. If you're choosing 3 people, you're leaving 97. So every different way that you could choose 3 people, you're leaving a different 97 behind. Every time you choose 97, you're leaving a different 3 people behind. So there's a 1-to-1 correspondence here. That's why they're exactly the same. So we just noticed that the combination of 100 things taken 97 at a time, or I could read this as 100 choose 97, is the same as 100 choose 3. Because 3 and 97 add up to 100. So in general, what would the formula be here? What could I write here as a general formula? C n choose r is the same as n choose what other number? N minus r. Remember, that's my n and that's my r. And so up here, n and r, that's n factorial, that's n minus r factorial, and that's r factorial. So these two, since r and n minus r plus r, since they add up to n, we know those will be the two numbers will be equal to each other. All right, 14. Now, don't get lazy here. In a race with 10 runners, in how many ways can first, second, and third place prizes be awarded? I remember the answer because we've been over the same problem in another video. Is this a combination problem? Absolutely not. First, second, third, order matters. 1, 2, 3. Here's the first place. How many possible people? 10. How many possible people for second place? Everybody except for the one who came in first. Third place, 8. 720. So we went back to permutations for a minute. Now, what kind of a problem is this question going to be? This was a permutation problem. Order mattered. Instead, if $50 is given to the first 3 runners, doesn't matter what order they came in, $50 goes to the first 3 runners. And how many different ways could those $50 be given to three different runners? This is, in other words, if person A, person B, person C came in that order, person A was in first, person B second, person C third, they all get $50. But if it came CBA, they still get the same $50, and that's still the same set of 3 people. Order does not matter in this case. We're just saying, out of a group of 10 runners, how many ways could I choose 3 of them? We're just giving $50 to the top 3. So, in this case, we get the combination of 10, selecting 3 at a time, choosing 3 at a time, 10 factorial over. 10 minus 3 is 7 factorial, and then 3 factorial. So this would be 10 times 9 times 8, and then that's the 10 factorial over the 7 factorial, just 10, 9, 8, just like above here. But now we've got this 3 factorial underneath it, which is 6, but I'm going to write it down like 3 times 2, because I want to cancel. The 2 and the 8 cancel to give me a 4 on top. The 9 and the 3 cancel to give me a 3 on top. So this is going to be 10 times 3 times 4, only 120 ways now, because order doesn't matter.